Okay, so I've got this exam question here, yeah? The first bit up here says, express 4 minus 10x minus x squared in the form p minus x, open brackets, x plus q all squared, yeah? So clearly we need to complete the square. Personally, this bit here, this negative x, I'd like to rearrange. So I'm going to say, and here's my paper, I'm going to say minus x squared minus 10x plus 4. It's the same thing, it's just written around in a slightly different order. Now, if I take this negative out, and I factorise it out of the x squared and the 10, and then I'm just going to leave my plus 4 hanging out on the outside. Now I can complete on this, so I leave my square brackets in there, x plus 5 all squared, then minus 25, yeah, the 5 squared taken away. We always take it away because it would always be extra. Then plussing on the 4. Now the minus hanging out here on the outside, I need to multiply that all back through. The key bit is it's going to change this minus here. So I'm going to get minus, open brackets, x plus 5 all squared plus 25 plus 4. Now as we can see, I've got 29. That's the value I wanted first in my question up here. So I want 29 minus x plus 5 all squared. Yeah? In this case, p is equal to 25 and q would be equal to 5. Yeah? Done. So now let's have a look at the next bit. So it says, hence write down the line of symmetry. Yeah. Now there's lots of things I can tell from this completed form. Yeah. And let's just make sure I've labelled that up here. And then A, I. This is only a 1 mark question. Yeah. So I only need literally to state the answer, and the answer is x equals minus 5. Yeah. Now it needs to be x equals. Yeah. Because otherwise it's not a line. If I just write minus 5, I'm going to get no marks here. Okay, next part of the question says the curve has the equation as the one we've been using, yeah, and the line has the equation, and we've got some kind of k constant here. Remember, this is just a number at the end of the day, where k is a constant. It tells us that, yeah, so any kind of number. Now y equals and y equals, yeah. So show that the x coordinate of any point of intersection. Now intersection, we straight away should be thinking simultaneous equations. And that's now fab, because in this question I've got y and y equals. So my starting point is to set this out. I'm aiming to show this, yeah, so I've got to make sure I work towards that. So bi. So we've got 4 minus 10 minus x squared is equal to k 4x minus 13. First thing I'm going to do is I'm going to expand out by k, so I'm going to get 4kx minus 13k is equal to 4 minus 10 minus x squared. Then I need to basically get all this to one side. Now it always seems logical to me to have x squared positive, so I want everything to go that way, yeah. So I'm going to say that 0, because that's all I'm going to leave on this side, would be equal to x squared, because it's going to go positive. Missed an x there and there, sorry about that. Plus 10x minus 4 plus 4k x minus 13k, when it's all rearranged onto that one side. So now I just want to group my like terms, yeah? I'm going to change my order and stick my 0 on the other side as well. So I've got x squared plus 10x plus 4kx minus 4 minus 13k is all equal to 0. Now I've got x in both these terms, so I can simplify that. So I've got x squared plus, open brackets, 10 plus 4k x. This has all got a common factor of minus or the minus, so minus 1, so I'm going to take the minus outside. In the bracket I can have 4 plus 13k is all equal to 0. I can still factor out the 2, which is common between this 10 and this 4, so I can then say that is plus 2, 5 plus 2k, x, and then again it would be minus 4 plus 13k. But if I look back at the question and what I've kind of already got here, see that I wanted 2 and an x on the outside, and 2k plus 5 and that, and 13k and plus 4. So I've got everything, but I've not quite got it in the right orders in my brackets. Now my signs are both positive, so it's okay. So I just need to literally show the examiner, therefore, x squared plus 2 lots of 2k plus 5 lots of x minus 13k plus 4 all equals 0. Done. 1 mark. It's quite a lot of working, but it's all quite straightforward. Yeah. So looking towards the next bit of the question. Yeah. It says given the curve and C line is 2 distinct points. Now this is really, really important. 2 distinct points. Now we should be using b squared minus 4ac. This helps us with points of intersection or roots, or sometimes we even use the word solutions. B squared minus 4ac, if there's 2 distinct roots, has to be greater than 0. Notice how that is a greater than sign as well. So essentially from the above equation, I know my values of a, which is obviously in this case 1. This is all my value of b, and this negative and all this bracket is my value of c. Yeah. So if I go back to my answer section, then b I'm subbing in my value of b, which is 2 open brackets 2k plus 5. Now this is all b, so I'm going to make that clear by just boxing that in some nice square brackets, and b squared minus 4 lots of a in this case is 1, and c, which is all of this including the negative, remember, so negative 13k plus 4, and in this case we want that all to be greater than 0 to give us 2 distinct roots. Yeah. Now I'm going to quickly square this. At the moment I'm just going to square the 4 and just put the squared onto the bracket. Now that's minus 4, and then I've obviously got the other minus, and then the other bit of the bracket, they're all greater than 0. Now I've got a 4 in front of both of these, so I can divide through by 4, which would leave me 2k plus 5 all squared. Then it would leave me minus 13k plus 4. Now that minus times that minus is going to make this whole bracket positive. So I'm going to end up with positive 13k plus 4. And then I just need to sort out this bracket here. Now when I square that I'm going to get 4k all squared. Now 2 times 5 will give me 10k, but I'm going to get that twice, that's plus 20k, and then I'm going to get the plus 5 squared, which is going to give me plus 25. When I then add that all up, I've got 4k squared plus 33k plus 29 is greater than 0. Okay, last bit of this question then. So it says solve the inequality. Now when we're solving inequality, we've got to remember our 4 steps. 1, we're going to need to factorise. 2, we're going to need to write our critical values. 3, we're going to need to draw our sketch. And then finally from our sketch we can solve. Yeah. So taking this 4k squared, which I've managed to show, so up here I've got 4k squared plus 33k plus 29. It's got to be greater than 0. Well, only options to make 29 thankfully are 29 and 1. Now if I do 1 times by 4 and then add it onto the 29, I'm going to get my 33. So my brackets are 4k plus 29, k plus 1, yeah, is greater than 0. There's my factorised form. From that I can state my critical values. Well, k is got to be equal to minus 29 over 4, and then from the other bracket k has got to be equal to minus 1. So that's steps 1 and 2, so I now need step 3. Yeah? I need to draw a little sketch. Now my little sketch can be very quick with these. So that's minus 1, and this is obviously minus 29 over 4. And then I have to look back up in my earlier part of my question. What did I want? I wanted greater than 0. So greater than 0 is this bit above here, this bit here, and this bit here. Yeah. So then I can say what k needs to be. So k would need to be greater than minus 1 for this half to be true. And k also needs to be less than, or also can be less than, minus 29 over 4. Because on my sketch these are two separate bits which are working at the same time, I'm going to leave them as two separate answers. Therefore, that's me all finished. Hopefully you found that useful. Feel free to comment below, etc.